Hello guys. Today we have the topic electrostatics, and it is simply electro and plus statics. What is electro? Electro is electricity. Electricity is due to the flow of electron, and flow of electron is charge. That is what causes the charge. So simply we have charge. I'm denoting it by CHG plus rest. So this is charges at rest. That is what electrostatic is. So we're going to talk a lot more about charges, what are charges and what kind of charges are there. So there are basically two kind of charges. One is positive charge and the another is negative charge. This is a positive and this is a negative charge. So I'm just making it a little more visible. That's a positive charge and this is a negative charge. And so what happens, two opposite charge, these both are opposite charges, they are attracted towards each other. They just get attracted, and that's what happens all the time. And this charge is attracted to it. Oh my gosh. So there is attraction between unlike forces. I just don't go upon this. It should be similar. It should be similar in here. The distance is bigger here. Doesn't matter actually. So when there is an attraction, so what we see here is there is an acceleration. Acceleration. Yes, that is it. So we know that electron has a mass. Electron has a mass that is something about 9.1 into 10 to the power minus 31 kg, and that is the mass of the electron. And similarly there is some mass of proton. I don't remember it right now. So there is a mass and there is acceleration. So we all know where there is a mass, there is an acceleration, there is a force. So before that we must do a little more. We can have another, this is a positive charge and this is another positive charge. Here, to the contrary to the previous one, we have the similar charges. So these similar charges ripple towards each other, means away from each other. These both, for sake we have taken these as positive. So both charges taken positive. You may take here these both, this one and this one, negative. So these just ripple each other, and there is acceleration similar to the other one. We have a similar kind of acceleration right here even. So this here is an acceleration and here is an acceleration, and again we have mass in both of this. So what we basically conclude is that here is a force that is acting, and this force is electrostatic force. So you can just write it electrostatic like this, and it is a vector quantity, but I'm just taking the magnitude, so I'm not putting it up. And what is this force? It is not very different from the gravitational force. The gravitational force is very much similar to it. I'm just writing its formula. This is K into charge 1 and then charge 2, Q1 Q2, and distance between them, that is d square of the distance between them. This is d. This is d, and it is very similar to the gravitational force, we have that is Fg, and the formula is very much similar. We have G, capital M, and then small m, or you can write m1 m2 by r square, and r was the distance between the two masses. So it is very much similar, but what happens, the gravitational force is just an attractive force, but the electrostatic force may be attractive or repulsive. It is just attractive, that is uh, attractive and it can be repulsive 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 and repulsive and attractive. So that is it, attractive. So that is the main difference between them. Otherwise, there are some differences. Here we have masses, and here we have charge. Here we have taken Coulomb's constant, and here we have gravitational constant, and the values are also different. It is somewhere about 9 into 10 to the power 9 9 to 10 to the power 9. I'm also good at this, so I'm just giving you something like that, and it has value of 6 point some, I don't remember it right now. You can check it up from anywhere else, but these constants have different values. So let's head up on to the next slide. We have a new, don't save, and just put this color here. Alright, so we did the electrostatic force, and in electrostatic force we have a lot to discuss. The K in the electrostatic force, that is what it was, F is equal to Fe is equal to what do you call, K into Q1 Q2 by R square, or you can take it D square. Anyhow, you have to just give your distance here. So this K is a constant that is called Coulomb's constant, and it is 1 upon 4 pi epsilon naught, and this is electrical permittivity. You will study about it later. It is an easy thing. So this is K, and the value of this thing is 9 into 10 to the power 9 newtons meter square per Coulomb square. And it is easy to find the this Newton meter square per Coulomb square is unit. How you can find it? You know, this R is in meter, and because of that it becomes meter square, because it is R square here, it becomes meter square, and you have two charges here, and therefore here it is Coulomb square. And you know, forces in newtons, so you can just, K is equal to, just solve the equation. You can get K is equal to Newton, and this meter square goes up here, and this Coulomb square goes down here, so you have Newton meter square by Coulomb square. So that is the electrostatic force, the constant K. And another big thing is the electrostatic force. If it is negative, then the forces, then it is attractive. The electrostatic force is attractive, or you can say that the charges given to us are opposite, or they are unlike, like they are plus minus charges are there, but never similar charges are there. And but when the electrostatic force is positive, I just have to write it here so that you don't forget it or you don't miss out with it. If Fe is negative, then attract attraction. Attraction. Attraction is there, and if it is positive, then repulsion. So that was easy. Repulsion and attraction. I'll just tell you about it later in the next slide. One second. We have this.